We're going to model exponential. Here we're modeling exponential functions using tables. What we are trying to figure out is, ideally, what is the function going to become when we extend the pattern, and come up with different values that we don't have to keep extending the pattern to get when we plug in that number. So the long way to do this problem would be to figure out what's being multiplied or divided each time to get you to the next step and move that table all the way until you get to 10. So I could just say, I look at 2 and I want to get to 4, and I want to get to 8, and I want to get 16. I could say, what could I multiply 2 by to get to 4? And what could I multiply 4 by to get to 8? And that one's pretty simple. You just have to multiply by 2. So if I want to know what is f of 5, then I would do 16 times 2. And that would be 32. And if I want to know what is f of 6, again, I would just take 32 times 2. And I would get 64. So I could continue that pattern going for 7, 8, 9, and 10. It's a lot of writing there, but you can squeeze that in if you make the space for it. And sometimes you'll need a calculator to help you out. So I'll, of course, use my calculator here. 64 times 2 is 128. 128 times 2, 256 times 2, and 512 times 2. And I think that's my 10th term. Let me double check my table. So 64 times 2 is 128. 256, 512, and 1024. So f of 10 is equal to 1024. That's not really how I would do it every time. What I really want to look for is, can I model the function f of x equals a times b to the x power? And if I can come up with an a and a b value, then all I have to do is plug in the number 10 and I'll get my answer. So the b value is always going to be what you're multiplying by to get to the next number. So I know it's going to be a times 2 to the x power. My a value is my y-intercept. That's going to be 0, comma a. So I would have to know, what is the value of f of x when x is 0? So if my table has 0 in it, that's the number. But if it doesn't, then you need to know what that number is. So you can backtrack on this table. If I'm multiplying by 2 to get to the next number, then I would have to divide by 2 to get from the x value of 1 to the x value of 0. So 2 divided by 2 is going to be 1. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. So if I know my a value is 1, then that's going to be 1 times 2 to the x power. So now I can just plug in 10. 1 times 2 to the 10th power. And let's verify that on the graph. And there's your 1024. So f of 10 equals 1024. All right, try this one. What is f of 7 for question number 2? I have a table starting with 0, 1, 2, 1/3, 1, and 3. So what is that pattern being multiplied? Try this. See if you could figure out f of 7. Pause the video and figure it out, and you can check with me. Okay, I have the answer here, 729. And hopefully you got that. Figured out the pattern here is being multiplied by 3 each time. So 1/3 times 3 is 1. 1 times 3 is 3. And you can continue the table down here. You can also note that it starts at 0. So your A value is going to be 1/3 in this case, and your B value is going to be 3. And you could simply do f of 7 is equal to 1/3 parentheses 3 raised to the 7th power. And that should give you 729. And just so you can see the connection between the exponent and multiplication, 1/3 is your starting value. Okay, that's your A value. And that base, that 3, you're multiplying that 3 by itself 7 times. And so that's the same as 1/3 times 3 to the 7th power. Those are the same value. And you see they both give you 729. All right, try this last one on your own. You have x, f of x. You have 1, 3072, 2, 768, 3, 192. We want to know what is f of 6. This one is a little bit trickier because it's decreasing. It's exponential decay instead of growth. So let's think about, let me give you kind of a starting point here. You still want to divide. So if I did 768 divided by 3072, what is that equal to? 768 divided by 3072. This is 0.25. Or if you click the fraction bar, that's 1/4. So 1/4 is meaning that it's going to be decaying. In other words, you're dividing each term by 4. So if you divide by 4, or that's the same thing as multiplying by 1/4. So times 1/4 is the same as dividing by 4. That's your base value, 1/4. That's less than 1, so it's going to be decay. So we want to know what is f of 6. So we can just keep dividing by 4. See if you can figure out the remainder of those to get to 6. (192) divided by 4. So 48 would be f of 4. F of 5 would be 12. And 12 divided by 4 should be 3. So 48, 12, and 3. So if you times by 1/4 or divide by 4, you'll finally get to that f of 6 value is 3. Now what I think about is that 1/4 is your base. So it's going to be f of, we'll just say f of x for now, equals a times 1/4 to the x power. And our a value, remember that's the 0, that's the y-intercept, so that's 0 comma a. So it's not going to be 3072 because that's not 0, that's 1. So you'd have to go up to 0. And in this case, since we're dividing by 4 to get to the next one, we want to times by 4 to get to the number that would be the y-intercept. So 3072 times 4 is 12,288. So that's going to be your starting value. So your final function is going to be f of x equals 12,288 times 1/4 to the x power. And if we plug in 6, that should get us 3. So 12,288, parentheses 1/4 to the 6th power is going to be f of 6. And let's verify that we get 3. And we do, and just a reminder that that's the same as 12,288 times 1/4 times 1/4. Again, multiplying by 1/4 is the same as dividing by 4. And so that's really what our table is giving us. So your answer is 3. And thanks for watching.